What is a zero-shot prompting? A zero-shot prompting technique is a kind of prompting technique where the large language model is just responding on the basis of its pre-trained knowledge. Okay? So the large language model is just working on the basis of its pre-trained knowledge. So you take some data, you train a large language model, you train an LLM, and just on the basis of that pre-trained understanding, the LLM is working. That is what we typically refer to as zero-shot prompting. Let me give you an example to highlight this idea even further. What I mean to say, because all these language models, if you see, the GPT-4 Omni model, particularly the one that we, it's a very powerful model, right? It has been trained with a tremendous amount of data. So it has been trained with a lot of data. And next time you ask it some question, the GPT model will generate a response based on whatever pre-trained understanding it has. You don't need to give it some other information. It already knows. Like if I when I go and ask it, okay, what is usually the weather in Delhi? It understands it. Okay, so next time you gave it a question and you asked it, what is the sentiment of the review? It just knew it. It knew whether the sentiment is positive or negative. That is what we refer to as zero-shot prompting. So the language model is able to use its internal understanding of how things should work. That is what we generally refer to as zero-shot prompting. So let me give you another analogy. Let me give you a better analogy of what I am talking about. This is one of my favorite articles actually, which talks about zero-shot prompting in a very nice way. All of you can take a look at it. Now, if you look at this example, I have a question for all of you. Okay, the question is very simple. The question is, you have to match the following. I give you five symbols, and you have to tell me which of the classes does the symbol belong to. Think about it. Like, I'm sure everybody is able to answer, but think about what's going on behind the scenes. We are all human beings, right? So we can say that we are all well-trained, powerful language models, right? So each one of us in this audience, we are all like LLMs. We are all like GPT-4o. We've all been trained with 30, 35, 40, maybe in some cases 45 years worth of data. We are all well-trained models, trained on a tremendous amount of data, and we all have a very rich understanding of things. We all understand things very well. So we are all well-trained models. That's part number one. So given a generic question, we are all able to answer. Now, before you came to this class, I don't think anybody has ever seen a symbol like this. Nobody in this class came prepared that I will ask you this question, did you? I don't think anybody did, right? This was the first time in your life you're probably seeing a question exactly like this. You did not prepare for it. You did not prepare for seeing a symbol like this. But we understand that this is similar to this. Not that we studied it, but just that we have a pre-trained understanding of it. That is what zero-shot learning is all about. We are doing zero-shot learning all the time, like in these kinds of pattern matching kind of use cases. We're not prepared in advance. We are just able to use our own intelligence. We are just able to use our own generic understanding of the things around us, and we're able to answer questions, generic tasks. And language models are very good at it. Language models are very good at performing this kind of zero shot kind of thing. So much of the prompting that we saw, including the first two examples, like the summarizer we saw and the information extraction use case that we saw, is basically zero shot, because the language model inherently understands, by looking at any kind of text data, what is typically an age what is typically a weight, what is typically smoking, what is typically gender, and what is typically diagnosis. The language model inherently understands that. You don't have to explicitly teach it, train it, and any of that stuff. And that's a very, very powerful attribute, Now, let me give you one more example. So zero shot learning works most of the time. It works very well, and it's a very, very good baseline that we typically use. But what are some limitations? What are some challenges? What are some limitations of zero shot learning? There must be some scenarios where we cannot use it, right? So let's talk about that. Let's talk about that. So, and you can keep going on, right? You can keep going on. Go to one more exercise. We know it, right? We know that this symbol is similar to this. We know it, right? So we know that this is similar to this. So as I told you, like before you came to the class, you didn't prepare for it, right? Now, let me give you one more use case. So the use case is, uh, let's say I'm a very well-trained model on Python. This is me, and I know Python very well. Okay, because that's the subject that we are learning and we are trying to code in Python, all that. So let's say I know Python very well. I have a very, very good understanding of Python, and I am faced with a question. The question is not this anymore. The question is like, the question that you're asking me is add two numbers in JavaScript. Now, now for those of you who don't know, JavaScript is a slightly different language. Okay, so Python is a much simpler language. JavaScript is very much like a C type of language. You have to do some other things like even declaration of variables, all that you need to do. It's pretty manual in some cases, right? Okay, there are objects and all that, so it's not exactly as easy as Python. So let's say I don't remember the JavaScript syntax that well. I know Python very well, but I do not know how to code in JavaScript. Let's say as an example. So what do I do? Will zero shot learning work now? So I'm the language model. I'm GPT-4o. You ask me a question, add two numbers in JavaScript. Can I write that program for you? Unfortunately, I can't. Okay, unfortunately, I can't. So what I need is, I just need a few examples to see. That's it. I don't have to start from scratch, spend 2 months of time, learn JavaScript, and then come back and answer the question. No. But let's just say I have enough pre-trained understanding of programming fundamentals. Let's say if I know Python very well, I already know a lot of programming concepts. Control structures, looping statements, conditional statements, operators, variables, assignments, everything I know. What is most important is the algorithm, the thought process, the thinking structure. All I need to figure out is the syntax. So the idea is, if you show me two or three examples in JavaScript, I will figure out the syntax. Okay, that's it. This is what we call few shot prompting, where you already have a very powerful language model and given a completely different task that the language model doesn't know or has never seen in the past, a slightly more specialized task. This is not a generic task like pattern matching. Pattern matching we are all able to do, right? But if it's a more specialized task, then it needs some examples to learn. And that is what we call few shot prompting. So in this case, what I will do, I will need a few examples to learn. So we will have a system message. So coming to the prompting part, we will have a system message and we will have a user assistant interaction. Few shot. This is my few shot examples. User one, user assistant one, user two, assistant two. This is my few shot examples. We will call it few shot examples. And these are the examples that the model will learn from. The system message will be add two numbers in JavaScript. User message one will be what? What will be the user message one? User message one will be okay. Subtract two numbers in JavaScript. And assistant one will be what? Assistant one will be the complete JavaScript code. So the idea is you're giving some examples. You're kind of teaching the LLM that if the user message was like this, subtract two numbers, the assistant response will be like this, where the complete code is I'm printing out, right? And the user message two will be something like multiply two numbers. If the user message is like this, the assistant response will be like this. And this is how I'm basically telling the large language model, which is already a very powerful pre-trained model. I'm just showing it two extra examples for it to learn better, for it to just pick up the syntax that, okay, now you just see what addition looks like, what subtraction looks like. So I give you two examples, and that entire thing is my prompt now. And I give the new user question. Remember, the new user question was what? Add two numbers. This is the new user input, right? And this entire thing is part of my prompt. I will add parameters. Remember, this is always plus parameters. We always do plus parameters. So we will do plus parameters. Parameters will be your temperature, max tokens, all those kinds of things. And this is how you make the API call. And then you get a response. And that's the idea of few-shot prompting. Few-shot prompting is a very, very powerful approach that large language models use. And it's a very, very powerful thing because even without training the model, like in this case, although I do not know JavaScript, I don't have to go back and train myself on JavaScript and come back. So even with my limited understanding of JavaScript, even with no understanding of something, just with two examples in the prompt itself, we are able to answer. And that's a very, very powerful thing, you know. So the model doesn't have to do the entire retraining. You don't have to retrain the entire language model. Retraining is a very costly process. It might take months to years of time to retrain the model with fresh data. We don't have to do that. But just by giving two to three examples in the prompt itself, you are able to kind of make the model perform very well in new tasks. And this is a very, very powerful thing called meta learning. Can you see? Model agnostic meta learning. It's called MAML. It's a particular term that we use, and it's very, very powerful. LLMs demonstrate this kind of behavior. Even without training the model specifically for certain tasks, you are able to give few examples to make the language model learn what the outcomes will be, right? To extend the conversation, and just to show you a couple of examples how it looks like, we can see these are a few examples with respect to the usage of these max tokens and all that. You can see this from the notebook. This is not very hard to do. So this is a simple example where we are trying to create a marketing uh, advertisement for the company. System messages, you're an assistant to the marketing team and help the team create an advertising content for the company. Okay. And user input is nothing but the laptop specifications. Razer Blade is a laptop. So based on the laptop specifications, your objective is to create a marketing advertisement. The only thing is that we are keeping the response limited to 200 tokens. Can you see we are saying max tokens equal to 200. So this is another one of the system parameters. Okay. So temperature we talked about max tokens. Okay. Let's scroll down. This is temperature. You can see the temperature demo. And this is what I wanted to demonstrate. When I say temperature equal to 0.8, which is pretty high, and I also use something called n equal to 3. What is the meaning of n equal to 3? N equal to 3 means you will give three responses. Okay. For the same prompt, for the same API call, we will end up generating three responses. Three responses will come. And when I have a high temperature value, I told you already, when we have a high temperature value, remember that the variability is very high. So in three, we are getting three responses, right? And in all these three responses, we're getting three completely we're getting three completely different advertisement things. You can see the first one is different, the second one is different, and the third one is different. Okay, this is what's happening when we take a higher temperature value. On the contrary, when I take a temperature of 0, you can see we are using temperature 0, max tokens 256 because we want to use maximum 256 tokens or 256 words, and n is equal to 2. That means I want to generate two responses, and you will see that here it's exactly the same. So because the temperature is 0, you can see the responses right now that are generated is exactly the same. So response 1 and response 2 is exactly the same. It may not always be the case. Maybe there's be some differences you will find, but here it is exactly the same, both of them. Okay, structuring prompts, few shot prompting. We already talked about it theoretically what it is. You can see the diagram beautifully clarifies exactly what we discussed. And this is how you will structure a few shot prompt. You will give a system message. You will give some few shot examples, few shot guide the language model. So few short examples are what will effectively guide the language model to do the entire thing. That's what the few short examples will do. And you will give the fresh user input. And the LLM will effectively generate the outcome. So that's how the few short examples can be incorporated. Okay, just to see one example how this looks like. This is the same sentiment analysis use case we are seeing. Classify customer reviews in the input as positive or negative in the sentiment. Do not explain your answer. Your answer should only contain the label positive or negative. Let me run this. This is the system message which defines the overall behavior of your system. User input, example one. So when the review is this, the response is this. Can you see? Look at it. User input, example one. The review is this. And when the review is like this, the sentiment will be like positive. You might be wondering, okay, why is it important to do it for sentiment analysis? Because sentiment analysis is such a generic use case, right? It's not necessary. The language model will inherently understand what the sentiments are. Is it positive? Is it negative? You can do it with zero shot also. But this will be typically relevant for cases where you want to fine tune the model more in line with your organization needs. Your company might have a different definition for what is positive, what is negative. Your threshold for positive or negative might be different, right? Maybe there are some companies that are more tolerant. Maybe there are certain domains where certain types of abusive words are very common. But if you go to a slightly different domain, maybe the abusive words are not very common. They are considered very bad. But if you look at some other domains, maybe certain types of words are considered very normal. So these kinds of few short prompts, these kinds of examples will help. The large language model, the LLM, is a very generic model. It has been trained on very generic data based on how things generally are. And it will do a fairly good job based on zero shot prompting. But few shot prompting is to fine tune the results more. Fine tune based on your use case, based on your organization, your domain. So you're giving it some specific examples for the LLM to learn. So you're explicitly saying that whenever the reviews look somewhat like this, the sentiment should be positive. And whenever the reviews are somewhat like this, the sentiment should be negative. And next time I have a new user review, that is your new user input. I want to generate the assistant response. And this is how you structure the complete few shot prompt. Can you see? Look at the code, all of you. Within square brackets, system, system message, user assistant, and the new user input. This is the new user input. And based on that, I will run the code. I'm taking temperature 0. And the model will generate the output response, which is sentiment positive. Straightforward. And we will see down the line how, this is a simple one with only two few shot examples, but it's not uncommon to have 10 to 100, even 100 few shot examples in a prompt. You're already starting to see how the prompt sizes can significantly increase. So the prompt is not just, okay, what is the weather today? A real world prompt can go up to several tens of thousands of tokens. And you're able to understand why. Because the prompt not just contains a user message, the prompt contains a system message, user assistant, few short examples, and it also contains the entire conversation history. So if this is part of a conversational chat, like what we were discussing a few hours back, so this entire conversation history is also part of my thread. Okay, so all the tokens are basically getting added up. Please be mindful of that. Okay, the costs are all adding up in a way.